All right, today we're going to look at direct variation, which is lesson 9.4. Direct variation is similar to linear functions. The difference is direct variation always has to go through the point 0, 0, which we'll kind of see when we start looking at what that equation looks like. So basically, when the ratio of two variables is constant, that is when you will get direct variation. Okay, so we're going to look at the formula for this. Y is equal to m times x. So we've already looked at a formula like this earlier. We've worked with these this week. The difference is there's nothing added or subtracted on the end here. So that's what allows you to always have the ordered pair 0, 0, because m, we know m is equal to slope. We've talked about that already this week, right? So you'll have a value plugged in for m. Then if you plug any number in for x, you can get an ordered pair, just like we've talked about all week. The reason you would always get 0, 0 is because if you plug in 0 for x, 0 times anything is 0. Okay, so we'll use this equation a little bit later on, but make sure you have that written down for our next few problems. All right, first here we're going to look at some graphs. Okay, it says 3 chains are traveling at a constant speed. For each, the distance traveled depends on the time as shown below, right? So it gives the time for train A, train B, and train C. Okay, now one's a table, one's a graph, and one just gives you an equation. All right, so the first thing on part A, it says what is the speed of each train? So we're trying to find it's meters per second. Okay, now the first one's easy because it shows you 1 second right here and how many meters that would be. So all you have to do is look at your chart. Everything here, when we're trying to find the speed of each train, if it's speed per second, we're looking when the seconds would be 1, right? So at 1 second, our speed is 35 meters. Okay, what about on the second one, train B? We're also trying to find when the time is 1, so look on the graph at 1 and go up to the graph. Well, what's the distance? 40 meters. So the speed for train B is 40 meters per second. All right, now notice on train C, it doesn't give us a graph or a table, so we're going to have to figure it out. Well, T represents seconds, so couldn't we just plug in 1 for T because we're trying to find how many seconds or the distance per second? So 45 times 1 is going to give you 45. Okay. All right, so then part B, which train is the slowest? Well, the one that's traveling 35 meters per second. So that would be train A. Okay, part C says, how far does each train travel in 3 seconds? Well, again, for the first two, you can just look at your graph. The first one is easy. At 3 seconds, it travels 105 meters. Same thing on the second one. I can look at the graph, find 3 seconds, go up. That is at 120 meters. Third one, again, I'm going to have to use my formula. Instead of 1, like I plugged in the first time, I'm going to plug in 3 because we want to know for 3 seconds. Okay, so then all you have to do is take 45, multiply it by 3, and you get 135. Okay. All right, we're going to do another one like that just to make sure we're clear and we know what we're doing. So this one is dealing with airplanes. It wants to know the speed of the airplane in meters per second. So again, same idea. If we want on airplane 1 for 1 second, we go to 1. Make sure you go all the way up to where the graph would be right here and look at that number. So this plane is traveling 500 meters per second. Train 2, again, we look at 1 second, or airplane B, airplane 2. 1 second would be 460 meters. And then the last one, we use our formula. 480 times 1 second is just going to give you 480. Notice when you're looking for 1 second, do you really have to plug that in, or could you just use the number that's given? Hopefully we see that we can use the number given. Okay? All right, part B, which train is traveling the slowest? That would be airplane B. I keep saying train, airplane. All right, so airplane B traveling the slowest because it's going 460 meters per second. All right, just like last one, it wants to know airplane A, how far does it go after 3 seconds? So I find 3 seconds, go up till I get to the graph. That would be 1,500 meters. Same thing for B. 3 seconds, it goes 1,380. 1,380. And then on the last one, we're going to have to plug that in. 480 times 3 seconds. You can type that in your calculator, and you get 1,440. Okay, so these are pretty straightforward. Notice all of them go through 0, 0, right? The graph here starts at 0, 0. This has an ordered pair of 0, 0. If you plugged in 0 into this equation, 480 times 0 is going to give you 0. Okay, so everything with direct variation has to go through the origin. All right? Okay, now let's get into some that are just a little more difficult. This is where that formula is going to come in for us. Okay, the one I gave you at the beginning. It says for a moving object, the force acting on the object varies directly with the object's acceleration. So the first thing we're going to do, y equals m times x. Now, it doesn't tell us how much it varies directly. We have to find that first. But it does tell us when it has a force of 60, I think it's newtons, acts on a certain object, the acceleration is 6 meters per second. All right? So that's the first thing we're going to do. This is what our y value, okay? 6 meters per second is our x value. So 60 is going to be equal to m times 6. All right? Okay, so then all I have to do to find out what m is, notice m times 6, so I'm going to do the opposite, divide both sides by 6, and I get m is equal to 10. All right? Now I'm only halfway there. Now I need to plug that in for m again, so I would get y is equal to 10 times x. Okay? So then it says if the force is changed to 40 newtons, what will be the acceleration? All right? So now I plug in 40 for y and solve for x. Okay? So we're going to divide both sides by 10. That means our acceleration is going to be 4 meters per second. Now, if you look at your example on this, they're going to use different variables than y, m, and x, okay? But they're working it out the same way. So just know if you look at the example later, they're going to use F equals k times a to show that this is the force and this is the acceleration. If you would prefer to use that, that's fine. You're going to work it the exact same way. Okay, so let's look at one more of those. All right, same idea. It says object varies directly. So anytime we see that, y equals m times x. Okay, force is what we're going to use for y. So we start with 15. Acceleration, 5 meters per second. So the first thing I'm trying to find is how it varies directly, so that value for m. Again, all you have to do is divide both sides by 5. So m is equal to 3. So it varies directly by 3. So then we rewrite this equation. Instead of y equals mx, you're going to plug that in for m, so we get y equals 3 times x. Okay, now this one's a little different. It says if the acceleration is 8 meters per second. So remember last time it gave us a new force, this time it gives us acceleration. So we plug that in for x to get our answer. 3 times 8 is equal to 24. All right, again, if you prefer to use F equals K times A, that way you know plug in force here, plug in acceleration there. You might use that to help you, okay? All right, last one. Donna is running. The number of minutes she runs varies directly with the number of calories burned. See the graph below, okay? So, number of minutes varies directly with the number of calories, right? Because if she doesn't run anything, she doesn't burn calories, okay? So, part A, how many calories is Donna burning per minute? Well, if we look at the graph, notice when you look at a graph like this, some people wanted to say, well, it goes up by 5 and it goes up by 25. Okay, well, that doesn't always tell you anything. You've got to look at the line that is being graphed. So what I like to do is go through and put points where it goes through an X and a Y together. Okay, so let's look at this first point here. So I look at, it says how many calories per minute. So calories is going to go first. So I have 50 calories in how many minutes? Notice at 50 calories, that's 5 minutes. So if she burns 50 calories every 5 minutes, all you would have to do to find calories per minute is divide. 50 divided by 5 would give you 10. Okay? Then it says, what is the slope of the graph? Well, here's how we have to be careful. Remember, slope is the change in y, which is here, over the change in x. So the first thing you need to ask is, how do these y values change? So how would you get from 5 to 10, 10 to 15? Well, we know that's going to be 5. Okay, then how are the x values changing? Well, from 50 to 100, 100 to 150, they go up by 50 every time. So all you have to do is simplify. Both are divisible by 5. We get 1 over 10. So make sure you're careful, because we did have some problems on our work from yesterday that both the question it asked for and the slope were the same. That's not always going to be the case here, because notice this said calories per minute. So we put calories on top, minutes on bottom, which is opposite of the slope. So just make sure you really read your directions, okay? Only 5 questions.